Hello friends, hope you are doing well. In today's video, we'll be studying about important problem types. These are the problems which has practical importance and also researchers are very much interested in this. So let's see which are these important problem types. So one of the important problem type is sorting. So totally we have 7. In that first one is sorting, second one is searching, and the third one is string processing problem, fourth is combinatorial problem, fifth is graph problem, sixth is geometrical problem, and seventh is numerical problem. So let's see each of these problems in more detail.
So here are some of the important problem types. So these are the important problem types. Now let's see each of these in detail. So first problem is sorting. So what is this sorting? Why you sort? Any idea why sorting is important? Yes, why we sort? Maybe you have sorted your wardrobe according to some category, like the dresses you wear at home, the dresses you wear at your when you're going outside for your college. Yes, that is one way of sorting. Huh? That is based on where you are wearing, you're sorting your clothes. Same way, many things you have seen telephone directory. How the values are sorted there? Any idea? That is based on the alphabetical order of your name. So this is one of the very important problem type. So let's see sorting in detail. So sorting problem is to rearrange the items of a given list in some order, like either descending or ascending. So here criteria for sorting will be ascending order or descending. So that is known as key. That is criteria to sort the problem is known as key. So next thing, this is one image which show you how the gems are sorted. That is, these are sorted by a particular criteria. So any idea how they are sorted? Yes, you're right. They are sorted by color. So here key is nothing but color of a gem. So let's see one example. That is to sort the numbers. So here are some numbers 4, 10, 5, 20, minus 5. If you sort them in ascending order, the answer will be minus 2, 4, 5, 10, 20. Whereas in descending order, the this order will be 20, 10, 5, 4, minus 2. Not only this, that's what just now we saw. That is the criteria while sorting the numbers are known as key. One more example we can see, that is to sort the records according to some alphabetical, or if we consider the student records, they can be sorted according to the alphabetic order of names or by roll number or by marks. So let's see this example in more detail. So if we take an example of a student record, for example, assume we have something called roll number, then we have student name and marks. So we'll take roll number as 213 and name as A B C D E F G H I and marks as 20, 100 and 60. So how to sort it? If you take the criteria, that is key is by marks, you are sorting by marks. So what will be the answer for this? So answer for this will be your first in ascending order we are sorting. So 20, 60, then comes 100, and then here also. So who has got 20 marks? That is ABC. So roll number 2. And then who has got 60 marks is GHI and 3. And who has got 100 marks is DEF and 1. So next thing is to sorting also makes the searching operation easy. So for example, you have seen in the dictionaries or in the telephone list how the this how telephones are. That is the list is sorted according to the alphabetical order. So this makes searching very easy. Otherwise, if given a telephone directory or something, it will be very difficult for anyone to search it, because it is not in any order. How you will search so many numbers? Even in student records, if you have student records and it is not alphabetic order, it will be very difficult to search. So your search operation becomes easy with the sorting. Not only this, for sorting, computer scientists have dozens of different sorting algorithms. They have discovered many and many algorithms for sorting because this is one of the important problem types, and many researchers and all, they have found many algorithms. You have insertion sorting, bubble sorting, selection sorting. So many sorting algorithms you will be studying in coming chapter. They are telling next point. There are few good sorting algorithm that sort a arbitrary array of size n using about n log to n comparison. That is, there will some algorithms which sorts with very good efficiency, but at the algorithm wherein key comparisons are done, which are sorted by key comparison, are better than the other. One more thing you have to remember, although some algorithms are better than other, but there is not no one algorithm that is the best. Some algorithms are good for certain condition, for certain machine, for certain type of input, and some algorithms are for some other type of input. So let's now see some of the algorithms, sorting algorithms property. So there are two important properties of sorting algorithm. That is, one is stability and the second is in place. So let's see what are these property. So a sorting algorithm is called stable if it preserves the relative order of any two equal element in its input. That is, if it is called stable only if it preserves the order of the two equal elements. For example, if an input list contains two equal elements in position I and j, where I is less than j, then in the sorted list they have to be in position I dash and j dash, such as I dash is less than j dash. So let's see this with an example. So let's say an example for a stable algorithm. So given some values, assume we have been given some values like this: 2, 5, 8, 7, then one more 8. So can you see here we have 2, 8. We have to sort this according to the ascending order. So when sorting in ascending order, we have to make sure that this first 8, which is first 8, it has to be in the first position compared to this 8. So now when we sort, what will be the answer? 2, then 5, then comes 7, then comes this 8 first. That is this 8, then we have to write this 8. So that is a meaning. That is, if something is having equal value, so which appears first, it should be appearing first, and which appears second, it should be appearing second. Otherwise, the algorithm is called unstable. So your algorithm has to be stable. So if we consider the example of unstable, it would be 2, 5, 7. This 8 would come here and this 8 would come here. That is known as unstable list. But your algorithm has to be stable. So next most important property is your algorithm has to be in place. That is, algorithm is said to be in place if it doesn't require extra memory, except possibly for a few memory units. So your sorting algorithm has to be in place. That is, it should not take any extra memory. That is the very important property of sorting. So now pause the video for some time and try to recollect what is told about the sorting. Just scribble down the points. That is, what is sorting, what is the key, examples, then what are the different sorting problems, and which type of sorting problems are good, and what are the most important things, what are the two properties of sorting, that is stability and in place. So just scribble down in a paper by pausing the video and then continue the. Now let's see our next problem, that is your searching problem. So what is the searching problem? It is giving that is finding something. So in our subject, given a list of elements, we have to search a given element, say key element. The element to be searched is known as key element. For given for values as you 10, 20, 30, 40, maybe you have to search whether 4 is there in this list or no. So this value which you have to find is known as key value. That's what is given. The searching problem is to find a given value called a search value. For example, given a list, say 4, 10, 20, 6. So you have to find something called maybe 20. That will be your key. So how you can compare? You can compare, is it equal to 40? Is it equal to 10? Is it equal to 20? Yes. So search is successful and it is at the position third. So this is nothing but your searching problem. One thing you have to note in searching problem is there is no single algorithm that fits all the situation best. Many searching problems are there which suits one type of problem, some other searching problem suits some other type of problem. That is, some algorithm works faster than other, but some might be slow but require, some may be faster, they require more memory, but some might be slower but they might require less memory, and some are very fast but they are applicable to your only sorted arrays. For example, your binary search, if you can it is very faster, but you have given list has to be sorted. And also you have some, there are some issues in searching. How in sorting we saw stability as well as in place, in searching also we have some issues when your underlining data will be changing frequently. So sometimes what will happen, when you will be searching, lot of data will be changing, that time as searching will become a challenge. And also in such cases we have to carefully select the data structure and algorithm. And also when huge data is there, searching also is challenging that time also. So those all things are challenges why for this searching problem. And also organizing very large set of data for efficient searching also is a challenge. So now just pause the video and scribble out the points you have seen in the searching and try to answer the questions given in your lesson plan. Third important problem type is string processing. So what is string then? You have studied it in first year also. String is nothing but set of character. Then what is this character? Character is nothing but a single alphabet or a number coded in single quotes, or anything special character also within a some whatever is there in a single quote. So that is nothing but a character, and this string is nothing but a set of characters. So string processing is nothing but a sequence of character from an alphabet. For example, hello. These strings are in double quote, whereas your characters are in single quote. And which are the strings of particular interest are? One is text string. This comprises of letters, numbers, special characters. And also another type of strings are bit string. Bit string in the sense, only bit means only two things will come, one or zero. So sequence of one and zero are known as bit string. And third is gene sequence, which can be modeled by string of characters from four character alphabet ACGT. And one very important problem in string processing is string matching. Now let us see what is this string matching. So given one string, hello, how are you? So this is a string. So what we can match? So one string can be given to match. For example, how. So what we have to do is, this is the string to be matched known as pattern. So in this problem, we have to find, in this sentence, that is, we have to find this string how. So you'll get it here. So various algorithm is there to do this. So in the coming chapters, you'll see all those algorithms. So hope you are clear with the third problem, that is string processing. Now pause the video for some minutes and scribble down all the points you have studied in string processing. and then continue with the video. And now the fourth problem is graph problem. So let's see what is this graph. Any idea what is graph? So graph is nothing but a diagram which consists of some sets of vertices and which are this attached by some edges. So let's see what is this in more detail. So graph can be thought as a collection of points called vertices, some of which are connected by line segments called. So we can take an example of a graph. So this is your graph. Sorry. So we'll take an example of graph and see what is vertices, what is edges. So this is my one of the graph. Okay. So it has four vertices. So V will be equal to A, B, C, D. So this is your vertices, and they are connected by something called edges. So our edges equal to set E. So AB, BC, CD, DA. Since it is a undirected graph, AB is equal to BC. Sorry, AB is equal to BA, BC is equal to CB, then CD is equal to DC, and DA equal to AD. So now let's see where these graph problems are used. That is, what are the application of the graph problems. They are used in variety of application like transportation, communication, social and economic network, project scheduling and games. So while solving these problems in computer, we use graphs for this all types of problems. And also there are basic graph algorithm problems. That is, graph algorithm this algorithms are they are, one is graph traversal algorithm. That is how we can reach all the points in a network. So now let's see what is graph traversal. So given a graph which has 3 points A, B, C. Okay, so these are the vertices. So graph traversal is nothing but you have to visit each of this vertices and at least once. That is known as traversal. So that we do in graph traversal. So next thing is uh, shortest path problem. So what is the shortest path? So given two cities, we have to find a shortest route to these two cities. And also some one more basic graph algorithm is topological sorting. And also some of the graph problems are very difficult to solve, and some problems can be solved only approximately and some problems cannot be solved at all. Some of the problems which can be solved approximately are traveling salesman problem and graph problem. So let's now see what is this traveling salesman problem and graph coloring problem. So the traveling salesman problem is a problem of finding shortest route through any city that visit every city at exactly once. That is, for example, if you are given with three cities, say Mumbai, Pune, and Bangalore. So, how you visit the city? Maybe you start with Pune, then you have to end to Pune only and visit the other two cities, such that your tour is the shortest. So you'll find many ways to do it, but you have to find the shortest tour. And second problem is graph coloring problem. So this what we do in graph problem coloring problem is to assign the smallest number of colors to the vertices of a graph so that no two adjacent vertices are of same color. So given a graph, this vertex is given red, this cannot be given red. So it has to be given some other color. You have to do such that you have to use minimum color. Now let's see the graph coloring problem. Assume we have this graph. Then, so what we can do is, now we have to color this such that we have used minimum colors and the adjacent, that is the vertices This vertex should not have same color like this, and this vertex doesn't have same color like this. So that has to be taken care. Maybe I'll start something called with blue here. So I'll color this edge with this vertex with blue. Then I cannot have blue here. I cannot have blue here. So what I can use is, maybe I'll use red here. So I've used red here. So I cannot use red here, and I cannot use red here. But I can use red here. So I'll use red here since this is not adjacent. Yes. So I cannot use only red here. Then can I use blue here? Yes. If I use, yes, I can use blue here because what is adjacent to this are red. So I'll be using blue here. So next, which vertex is remaining? Only this. I can't use blue here. Can I use red here? No. So I'll use something called green. So in this graph, with how many minimum colors I can use? That is without, so that adjacent vertices are not of same color. That is, I can use three. Three are the minimum this colors I can use here. This graph coloring problem has several applications. One of the example where this graph coloring problem can be used is during event scheduling problem. So you hope you have understood the fourth problem, that is graph problem. Now just pause your video and scribble down all the points you have seen in the graph problems, and also solve those examples. And the now next problem is combinatorial. Now let's see what is this combinatorial problem. These are the problems that ask to find a combinatorial object such as permutation, combination or subset that satisfies certain condition and has a desirable property. These are very difficult problems. That is, combinatorial problems are very difficult in theory as well as practical standpoint, because the combinatorial problem typically grows extremely fast with the problem size. That is, with the size of your input increases, the solution also drastically exponentially increases. So it is very difficult to solve. And some people tell that this there are no algorithm to solve combinatorial problems which solve the problem in acceptable amount of time. And third, also some computer scientists believe such problem doesn't exist only. Not problem, sorry, such algorithm to solve this combinatorial problem doesn't exist only. Hope you have understood the combinatorial problem. Again, what you have to do, just pause the video and scribble down the points I have told you. So now next problem is your geometric problem. So let's see what is your geometric problem. One full subject you have studied in your schools and also first year, I guess, about the geometry. So now let's see what is this geometric problem. So now let us see some of the geometric problems. So what are these geometric problems? These are the problems which deals with geometric objects like points, lines or polygons. Points are nothing but a single dot. Lines are nothing but something that connects two or more, and that is two points. And your polygon is given n number of points which are connected by lines. So these are polygons. Some of the geometric problems are, one is closest pair problem, second one is convex hull problem. So closest pair problem is nothing but in a plane, if there are n points, you have to find smallest pair among them. Let's see now example. So can you see in this plane so many points are there. So this can be a convex closest pair because it is near to each other. This might be one more closest pair. So this two might be one more closest pair. This red also can be one of the closest pair. So you have to find in set of n points the closest pair among these. Next, one more geometric problem is convex hull problem. It asks us to find the smallest convex polygon that would include all the points in the set. So earlier we were only finding the smallest pair of points, but here we are finding the convex smallest convex polygon that includes all the points in the set. So here can you see in this many points are there. So here one inner convex hull is there. So many points are there. So they have drawn one convex hull. Hope you are clear with the last problem, that is geometric problem. So now let us see the last problem, that is numerical problem. These are the problems which involve the real number. So these are the numerical problem which involves the mathematical objects of continuous rate. The example: solving equation, computing definite integral, evaluating function. And these problems can be only solved approximately. We cannot solve it exactly sometimes because it will become huge for a computer to solve it. So now let's see one of the important questions of this video. So that is, write a note on sorting and searching problem types. This might appear for 10 marks, and also there is a quiz in the description box. Please take it, and any doubts you have you can comment in the comment box. So hope you'll understand this video very nicely, and taking the quiz to your problems will be solved. Any problem you can still comment in the comment box. So see you soon.